So the next topic is setting up the game managers. So to manage inventory and other game data effectively, we need to set up a data management system. So this system separates the background data from visible game objects, which is similar to the model view controller MVC structure used in web applications. So this allows for easy adjustments and flexibility in our code as the game develops. So why use a management system? Because it's one of the advantages. It separates how data is managed from how it's displayed or interacted with. So changing one part of the game, like the player's inventory, won't affect other parts. And the other benefit is with each manager's data handled separately, we can update or experiment with features like adding new items to the inventory without affecting other parts of the game. Uh, for more complex games like RPGs, this management system can keep large amounts of data organized. In contrast, similar games like a puzzle game would likely just track game state in a single controller script. Setting up the managers, we set up two managers, player manager and inventory manager. Player manager is will track the player's basic data, which is health or lives. Inventory data will store a list of items collected by the player. So these data managers acts as a model in the MVC framework, holding all background data. They also make it easier to build separate components that can update without interfering with the main game. And we also have main manager of managers. So a central manager called managers will oversee each data manager, which is the player manager and the inventory manager, and control their initialization at game start. Think of it as the controller of our data managers. By going through the manager's object, other scripts in the game can access any specific data model like inventory manager whenever needed. And we also have an interface for consistency. So both player manager and the inventory manager will follow a shared interface called iGame Manager. It's an interface that acts as a blueprint, making sure each manager has the basic structure and can be accessed the same way. So this shared interface also ensures that the managers can interact with each model consistently, treating both player manager and the inventory manager as iGame manager types. So for that, first we create an interface which is the iGame manager. The the iGame manager. So the iGame manager interface consists of a initialize method. I'm not sure. Yeah, it was not included in this code, but usually it has a void initialize, which is a that method is to set up the manager and a boolean called is ready. Not sure why it's not here, but yeah, you'll have a bool is ready, which indicates if the manager is ready to be used. And we also have a will then create uh, so we also have player manager and inventory manager. So each manager will implement iGame manager and use its structure. So here the player manager tracks players data like health. Here we also have we should have a initialize method which sets up starting health, and inventory manager which stores items in a list and includes an add item method to add items. And we also have a main manager which is managers. So the managers class will initialize all other managers, making them accessible to other scripts. So here we have static properties like player and inventory properties are static, meaning they can be accessed anywhere in the code with managers dot player or managers dot inventory. And we have a awake method. Each manager is initialized so that all data is ready when the game starts. So this setup provides a centralized access to data modules, making them easy to manage and adjust independently. So this type of structure is essential as games grow in complexity, enabling flexible data handling and efficient updates. So to manage game data like the players, uh, to manage game data like the player's health and inventory effectively, we are we should set up a structure system. As I mentioned, game managers. So these managers will handle different areas of the game, making it organized and easier to update. So first step would be creating an interface, the iGame manager. So in programming, an interface is like a blueprint for a class. It's lists properties and methods that any class using it must include. So in the iGame manager, uh, we have a status property which keeps track of whether each manager has started. It uses a type called a manager status, which we'll define next. And we have a startup method. This function will initialize each manager when called, performing necessary setup tasks. And we define the manager status, which is the so an enum, which is short for enumeration, is a list of specific values that a variable can have. So each manager can be in one of the states like shutdown, initializing, started. So these are the three states we'll be using. So each manager can be in one of these three states. By checking the status, other parts of the game can know if it's ready to use. And then and then we go to inventory and player inventory manager and player manager classes. So these managers will use the iManager game interface to structure their setup and manage different game data. So inventory manager is class is quite basic for now, but this code is like the final code. But so it follows the structure defined in the iGame manager. So will have a status property. So this property can be read from anywhere, but is set only inside the script. And we should have a startup. So startup, this method logs that the manager is starting and then sets its status to started. And in the player manager, so the player manager manages the player's health. So this manager also follows the iGame manager structure, but includes additional properties and methods for handling data, handling health. So we have health, max health, so which keep tracks of players' health, with the max health being the limit. And we should have change health method. Yeah, so change health method adjusts the player's health, making sure it stays between 0 and max health. And so there's a unity function, mathf.clamp. So this is the unity function that keeps values within a set range, uh, which is useful for preventing health from dropping below 0 or exceeding max health. Couldn't find it in here, but yeah, it should be there. Okay. So and next step would be managers, the main manager. main manager class. So the managers class link everything together. It starts up the other managers and makes them accessible to other parts of the game. So here we have static properties. So static properties, player and inventory are static, so other scripts can access them with players dot managers dot player or managers dot inventory. And in the awake method, awake method is a built-in Unity's method that runs once at the beginning before start. So here it gets components of players manager and inventory manager, then adds them to start sequence. And the startup sequence coroutine, which runs each manager startup method. It checks that each manager has fully started before continuing, so all managers are ready to use. And so in Unity, after this, you will create a empty game object, like a which acts as a placeholder. Name it like something like game managers and position it to 000, and attach the managers, player manager, inventory manager scripts to this game object. And when you run the game, you should see messages in the console showing each manager's starting up. So in summary, game manager game manager interface, which provides a shared structure of for each manager. The player manager, inventory manager, which manages different types of data like player health, inventory. And we have a main managers class, which controls the startup sequence for all managers and allows other scripts to access them easily. So this setup creates a clear structure of managing game data, making it easy to add more managers later if needed. So now each part of your game that needs player or inventory data can simply call managers, player or managers.inventory to access it, keeping things organized and efficient. So next is so to create a simple effective inventory UI that displays the collected items and their quantities, we need to make a few changes in the code. First is adding methods in the inventory manager to access inventory data. So the first step is to add two methods in the inventory manager class, so we can easily get data about items the player has collected. uh, Manager. So get item list, this method returns a list of all different item types the player has collected. It's a list created from from the dictionary that holds our inventory items, and the keys of dictionary are used to make this list. Each item name appears only once if even if multiple copies of it exist. And next, we need icons for each item to make our inventory visually appealing. For that, we create a resources folder. So in your Unity project, go to assets and create a folder and name it resources. So inside that folder, you can create another folder named icons. Then import images of each item like health packs, energy, keys, and place them in the icons folder. This lets us hold them by name in the code. So assets in the resources folder can be loaded using the resources.load in Unity code, making it easy to access them by name without manually assigning them in the inspector. And next step would be writing a basic UI script so to display the inventory. So now that we have access to inventory data and icons, we'll write a script called basic UI to display the collected items on the screen. So here we have a on GUI method, which Unity calls this method to render GUI elements every frame. It's an easy way to draw simple UI elements on the screen. And then we define layout settings. We set up values for positions, position X, position Y, dimensions, width, height, and spacing. Spacing is buffer for each spacing for each item box on the UI. And first, the code checks if there are any items collected. If not, it shows a box with no item. And If items are in the inventory, it loops through each item type, which is the load icon. It uses resources.load to load the current icon image based on the item name. And for the display item, it uses GUI.box to display the each item's icon and collect in a horizontal row across the top of the screen. And we have update position. So update position, after each item is displayed, it shifts the position X to the right by adding width plus buffer. uh, so each item lines up neatly next to the previous ones. And so this line, the list string item list, this line retrieves the list of items type. And so the GUI.box, uh, this line displaces each item in the box with its count and icon. And as I mentioned before, uh, this moves each item box to the right to create a row of items. So with these steps, you should have a inventory UI that retrieves item data and quantities from the inventory manager, loads and displays icons for each item type, and updates every frame, allowing the player to see their collected items in real time. So this setup enables easy to access inventory items and is ready for further enhancements like adding interactivity to clicks on items. So next is to equip a key in our game and use it to open locked doors, we'll modify the device triggerer script, add a equipment system to the inventory manager, and create uh, a UI display to manage these interactions. So first we need to modify the device triggerer to require a key. So the device triggerer script controls whether an object can be triggered, like door opening. We'll add a new setting to this script so that certain doors can require a key to open. For that, first device. So for that we need a boolean variable require key, which when this is checked in the inspector, the door will require a key to be triggered. And we'll modify the on triggerer enter uh, method to check if the player has the key equipped. If the required key is true, the script will only let the player operate the door if their equipped item is set to key. And so basically the required key is a boolean which is true or false, that will set to true if a door requires a key. And the on trigger enter method runs when something enters the trigger zone. Here it checks if required key is true, and if the equipped item in the inventory manager is not key. If both conditions are met, the code exits early, stopping the door from operating. If the player is equipped the key, or if required key is unchecked, the door can be opened as usual. So next step would be adding a equipment system to the inventory manager. So So next we'll make changes to the inventory manager to handle equipping items. Specifically, we should create a property called equip item that stores the name of the currently equipped item, and we should have a method called equip item to equip or unequip items based on players input. So here equip item is a string that stores the name of the currently equipped item, and so equip item checks if the item name given is in the inventory. So items dot contains key name and isn't already equipped. If both are true, it sets equipped item to that item name. If the item is already equipped, it unequips it by setting equipped item to null and printing unequipped. So this method returns true when the item is equipped and false when it's unequipped. And next step would be updating the UI to display and equip items. So to allow the player to see and equip items, we'll modify the UI script, which is the basic UI, to add a button for each item in the inventory. So basic UI. So on GUI will displaces both the equipped item and the equip buttons. So GUI.box uh, shows the currently equipped items in the top right corner of the screen, and a list of items, which is the item list, is retrieved from the inventory manager, and for each item a GUI.button is created. When clicked, the button calls the equip item to equip that item. So to test the complete system, check the require key option in the device trigger for doors to when you want logged, and pick up a key item in the game and use the new UI button to equip the key, and the door should only open if the key is equipped. So with these steps, we we should be able to create a system where doors can require an equipped key and the players can manage and equip items in their inventory through the UI. So this setup can be extended to manage different items and interactions in the game. And the last topic is health packs. So to enable players to use health packs to restore health, we'll set up a consume item method in the inventory manager script and add a button in the UI that allows the players to use health packs. So for that, we first add consume item for in the inventory manager. Inventory manager. So consume item. Yeah. So consume item, this method will uh, manage using up items for the player's inventory. Specifically, it will check if the specified item like the health pack exists and decrease the count of the item when used, and remove the item if it counts reaches 0. So here we have items dot contains key name, which checks if the item like health is available in the inventory, and then decreasing the item's name minus minus reduces the count of the specified item by 1 when used. And so if items name is equal to 0, meaning no items are left after using it, we remove it from the inventory to keep it tidy. And if item is not available, for instance, trying to use a health pack when none is left, it logs a message saying uh, cannot consume item name. That's the item name. So return types are return true if the item was successfully used, otherwise returns false. So by using this method, we keep the inventory updated and properly manage item usage. So next step would be updating the UI to add the use health button. So in the game's UI, you create a button that for the player to use health packs. So this button will show alongside the item in the inventory UI and also allows players to consume health packs, which will both decrease the item count and increase the player's health. So good. Yeah. So here for each for each loop uh, goes through each item in the inventory and displaying them in the horizontal row across the top of the screen. And the equip so for each item it adds a equip button uh, which equips the selected items when clicked. And also uh, if the current item is a health pack, an additional button labeled use health is displayed. Yeah. So clicking the button calls two methods, which is consume item health in the inventory manager, which reduces the count of the health packs by one, and change health 25 in the player manager, which increases the player's health by 25. And each item's position is adjusted again to ensure the item appears side by side. So this code effectively links the health pack usage directly with the player health, allowing for real-time health restoration. So when a player clicks use health, the consume item method will checks and updates the inventory, decreasing the health pack count. If the health pack is used, change health 25 is called to uh, increase the player's health by 25. And we also have display items, which display items function, which refreshes the UI, ensuring the inventory reflects the updated count. So some of the key features in this is first is inventory tracking. The inventory list automatically updates when items are used or removed. And other one is interactive UI. Players can directly use items from the UI with a update click. And the other one is error handling. So if the player tries to use a health pack with none available, they see a helpful message in the console. So this setup should give players control over their inventory, allowing them to use health packs or other items at any time. The UI and item can are flexible enough to adapt to any item type, making it easy to expand for other gameplay mechanics in the future. So this code provides a straightforward way to manage and interact with collected items, keeping the game organized and interactive. So that's the end of this topic.